So in this video, I'm going to discuss the ball distribution problem which occurred in yesterday's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram, or even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem was very simple. So this is the number of test cases, and you are given two numbers. One is n, and the other is m, and an array of size m. Okay. Similarly, n, m, and an array of size m. So what is given is that you have colors from 1 to m, and there are like of color 1 there are 5 balls, of color 2 there are 4 balls, and color 3 there are 4 balls. Okay, over here for color 1 there is 1 ball, color 2 there is 1 ball, and you have n boxes. Okay, so you have to find the minimum number of boxes which can contain all the all the balls of all colors. Okay, the balls of all colors. And remember one thing, in every box all the balls should be of different color, right? So let's say for this 5, so there is 1, 2, 3, 4 and 5 box. Okay, so first of all, the color 1 is in 5 boxes, all the 5 boxes, so I have to put it in all the 5 boxes. Okay, I put it in all the 5 boxes. Now color 2 is in only 4 boxes, so I can put 2 in any 4 boxes. So let's say I'm gonna put 2 in this 4 boxes. Okay, and the color 3 is also in 4 boxes. So I have the greedy approach will be first to put color 3 in the box which does not contain color 2, that is this box, and the rest of the boxes already contains color 2, so I have to like forcefully put it. Okay, color 3 and color 3. Remember one thing, when I was putting color 2, the greedy approach was to put color 2 in the boxes which does not contain color 1, but unfortunately all the boxes contain color 1, so we had to we can't consider that. Okay, so how many boxes are there which are containing 3 colors according to the greedy approach? That is the minimum thing, 1, 2, 3, right? So their answer is 3. For this there are 2 boxes, and you can put the color 1 is in 1 box, right? The color 1 is in 1 box, and color 2, as I told you, you have to put it as in greedy approach, that is in which the color 1 is not there, so that is over here. So how many boxes contains both the colors 1 and 2? 0, right? That is the minimum possible, so the greedy approach gives us 0. Now how you have to do is, I am going to give you a pseudocode type of thing. Okay, so initially you can say that the answer is like you have to go sequentially. Okay, you have to go in a sequence. So initially let's say the answer, initially let's first sort array in descending order. Okay, because remember one thing, whenever we are going to do we have to think of the greedy approach, the best thing is to sort in ascending or descending order. When we sort in ascending order, it means that we have to find the greatest something, and when we sort in descending order, it means we have to find the smallest something. And since it is given that you have to find the minimum possible, so this has to be in descending order. And once we are done with it, so let's say, so we can say that the answer is going to be the first element of the array, because let's say we have to, like, there are x number of balls on y1 position, y number on 2, z on 3, and so on. Okay, till m, till m, till m, right? So this is the thing. So x is always greater than equal to y is always greater than equal to z. Now it doesn't matter that whether it is in sequence or not, 1, 2, 3, it should be a permutation of m, right? It should be a permutation of m, this thing. So it may be like, over here it is 4, over here it is 5, over here it is 1, and somewhere over here it is m, and somewhere over here it is not, like the last element may be m minus 7, something like that. Okay, so first of all we can say that we are going to put the balls which are of color 4, okay, in x boxes, right? So initially the answer is AR of 0, because we are not going to consider the rest of the thing. We are just only going to consider that we have balls of color 4. So answer is going to be 4, because in all the 4 boxes we can put, in all the x boxes we can put the color 4, right? Now comes to y, right? So let's say we have got balls of color 4 and 1, that is till over here. Okay, so we can do one thing, we have to check how many boxes are not containing the color 4, right? As I told you in this greedy approach. So in those boxes we are going to put y balls, and if we are left with some balls, then we have to put it in this thing. Okay, so that is, let's say color 4 the color 4 was in X boxes and there were N boxes total. So now how many boxes does not contain color 4? It will be N minus X, right? And Y, where we have to put? We have to put Y in this N minus X, right? Now the remaining of the Y, okay, so whatever, so Y we have put in, that is the remaining, that is this portion we can put in the X boxes, okay, in the X boxes. Now remember one thing, let's say this number is lesser than X, right? So we can replace the answer by this number, okay, we can replace the answer by this number. But another thing, that what if Y minus N minus X is lesser than 0? Okay, what if it is lesser than 0? So let's consider one situation where it will be lesser than 0. So let's say after sorting, the thing looks like 5 3 3 and the value of N is 10. Okay, so initially there are 10 boxes and in 5 of them we put color. So let's say this is 1 2 3 and it is already sorted. So in 5 boxes we put 1, right? 3 4 5, in 5 boxes we put it. And after we have put it in 5 boxes, so we have to put this 2 in the remaining boxes, right? There are 5 boxes left, so we have to put it in remaining 3 boxes, right? So we can put 2 in remaining 3 boxes. And remember one thing, we are still left with 2 more, right? We are left with 2 more. So for this case, y is 3 minus N minus X, that is 10 minus 5, right? 10 minus 5. This is going to be 3 minus 5, right? That is minus 2, because we are left with more 2 boxes. But since we are left with more 2 boxes, at this position we can confirm that this is 1, this is 2. So in these boxes we can't keep 1 and in these boxes we can't keep 2. So once it is lesser than lesser than 0, that is we are left with some boxes, or lesser than equal to 0 also, that is we are not left with boxes, but like there is no intersection, okay, there is no intersection. Once we find something that there is no intersection, so we can directly say that the answer is going to be 0, because it is not possible to make it, right? So let me give you a pseudocode type of thing. Sorry, I was about to give you the pseudocode. So first of all, the first step will be sort the array in descending order, and the second will be answer is equal to AR of 0. I think I mentioned it here, I forgot to, so I am rewriting it. Answer is equal to AR of 0, and the third step is going to be run a loop from 1 to N minus 1 and make ARR of I as maximum of 0 comma ARR of I minus N minus answer. Okay, sorry, not ARR of I. ARR of I is going to be the maximum of this thing, is going to be this thing. Okay, it is going to be ARR of I, and answer is equal to ARR of I. Answer gets shifted. Okay, answer becomes ARR of I. So what this does is, if we go to a negative number, so this becomes 0, right? So this becomes 0, and since this becomes 0, so the maximum of both them will be 0, and the answer becomes 0 at that position. So you can do one thing, that if answer is equal to 0, you can directly break out from here, but it is not necessary. You can like traverse throughout the whole array and then print. Step 4 will be print answer. Okay, so this thing is basically the greedy approach thing, that is we are going to put the balls in as possible, like in the last element, that the previous element that we have traversed, the previous color we have traversed, we are going to put this present color in all the boxes which does not contain the previous color. Okay, that is a greedy approach. Or maybe all the boxes which contains all the colors from 1 to the previous number. Okay, so this is kind of like you can say it is a combination of greedy and DP. Okay, so that's it from my side. Thank you. I hope you get it. This one was a nice problem. So that's it from my side. And if you have any doubt regarding this, you can pick me up on Instagram and Discord server. The links will be provided in the comment section. I'll pin them. So thank you.